This is version 0.1.30 of what used to be Visual Swift and is now called SynthMaker. So there's quite a few new things with this version. When you go to the menu, you now have modules, and this is just the beginning. They will evolve over time. There will be more, and these ones are basically just for testing this mechanism of having modules. So for example, if we create a sine synth, you can go inside it and you have a very simple sine wave synthesizer, and I will plug it so we can hear it. Let's have a MIDI in which will bring MIDI events from my NanoKey Studio keyboard, and when I click on it, you should see a log of the notes. And now I connect to the audio out, and this is how you'd have your own very simple sine wave synthesizer. I'm going to expand this a bit, and I will start showing a few of the new components, like for example scope FFT. You can connect to, let's say, your sine wave and also your gate, so it knows which one was the last key played. And now when you play, you see an FFT. You see the spectrum of the sine wave, like a high frequency, a low frequency. Yeah, there's also one that shows the wave, scope wave, although it's not triggering when it goes past 0. So this you plug it the same way, and now you can see your sine wave. Okay, so instead of sine wave, I've shown before this oscillator that works with the tables, which you can create your own custom tables. And this one has 4 input tables. I'll show you the labels. So it has a phase input, same as the sine, and it has your audio going out. It needs to know how many harmonics it can play without aliasing, and I will show in a moment how that works and why it's important. And then the mix goes between 0 and 1, with 0 being the first table, third being the second table, 2/3 being the third table, and 1 being the fourth table. So I'm going to replace this sine wave. I'll just disconnect it. I can still leave it there. Now I'll connect our table oscillator. The output goes to our audio out, and now I'll show the spectrum and the wave. Now this table oscillator currently has no tables inside it. I think in the future maybe I will make it have some default tables so it works straight away, but for now you need to create your tables, and there is a component called wave selector. Okay, so this component allows you to create to select one of 4 waves, and they will go out of this connector to program your table oscillator. Now at the moment this will change maybe in the next version, but for now the tables are not calculated, so this needs to be done, but that will change in the future. It will be automatic. So I'm going to calculate all the tables. Okay, now these waves here, as you can see, they have some code there which you could change. For example, this frequency times 3 could have frequency times 5, and it updates the wave when you change the formula, the code. Okay, so now I'm going to make all these tables go out here. So the first one is the square wave, and let's see, what do I need? Square wave goes to 1. This isn't playing. Oh. So the phase is fine. Maybe I need to put the number of harmonics. I'm going to start with typing the number by hand. Let's see. Okay, so now you see that we have 10 harmonics, which in the case of a square wave is showing 5 peaks. But if we pick, if we choose sawtooth, you can see your 10 peaks there. So here, if you count, there should be 10. Now if you want 20, you go like this. Now the problem is when you go too high, you start getting aliasing. So you can probably see there that the harmonics all look fine, but when it goes over the end bit, they bounce back and they create aliasing. Now what we want is to have the correct number of harmonics all the way to the end without bouncing back, and the way you do that is with a component called frequency to n harmonics, and your frequency comes from there. I'll show the labels. So your MIDI events arrive here, and the top output of MIDI to voices is the frequency of that note, and from the frequency you know how many harmonics will fit without causing aliasing. So instead of 50, we should just have the correct amount, and you can see here, I'll put this on a separate window, you can see the harmonics going all the way to the end and stopping there. So it's just the correct number of harmonics. And go back to square wave. So at the moment we have a square, a sine wave with 3 times frequency, and this strange waveform. The wave that plays is like a blend between 2 of them, which is defined by this mix value, where 0 should be our square wave, then a third will be the sine wave, a 6 will be sine wave times with a frequency times 3, and the last one was that strange waveform. Okay, this can be modulated, so we could have our sine wave now with we need a phaser, and we'll plug here a slow frequency like 1 hertz is okay. Now I'm going to modulate the mix, but sine wave goes between -1 and 1, so I'm going to multiply it by 0.5, and I'm going to add also 0.5. Okay, so now when I play a note, it's modulating through all four. I'm going to make it go a bit slower with a frequency, let's say 0.3. Okay, so I'll show other things related with heavy modules. So these modules here, you can create your own. Like for example, we can have this master one. It has very little inside, it just controls the volume. But we could change it, like put a knob inside it. Let's see a knob. Where is it? Where is it? There. Now we could connect our knob to the volume, what our input is being multiplied by, and we could make it appear in the front panel like this. The yellow stuff is for UI stuff. So now we have our own master component with a volume, and we can export it by selecting it, export, and now master knob, and then when it's exported, it will be a file, and you can import it back. I'm going back. Master knob is there. I'm going to bring back is okay. So now the modules have this VS Mod extension. You can actually look inside to see the contents. It has a schematic, which is in JSON, and you can see the thumbnail as well. But this VS Mod file, you can drag it back. Oops, I did that wrong. Where is it? Master knob. You can drag it back, and this way you can create your own modules. Like for example, I'll show a chorus module that at the moment is bundled with the app, and these modules are really simple at the moment, but they will, I hope, quickly evolve. So here is a chorus which you can connect to your synthesizer. Okay, if you want to see how the chorus works, you can go inside it, and basically you have two delays. There's one there, and they have there's two sine waves, that one and that one there, and they have frequency of 0.6 hertz and 0.4 hertz, and they are being multiplied by 0.002, and you add 0.003, and they control your delay. Oops, the labels are wrong. I need to change those labels. So basically the delay has an input and an output, and the second input it controls the amount of delay in seconds, and this delay is interpolated, so you can modulate this the delay time with LFOs or whatever. So this is how we create a very simple chorus module, and if you'd want to control, like for example, the frequencies of these sine waves, you could put here two knobs, you could plug them to that yellow one, and they would appear in your front panel, and then you could select it, you could export it, and then in the future you could bring it in. Okay, so one thing you notice here is that these waves, they constantly playing at the moment. This oscillator runs 16 oscillators that are constantly running. I think to improve performance in the future, I think I will put an envelope input so that when the envelope goes to 0, it doesn't need to actually run the oscillators, because they're like lookup tables, and it is a little bit expensive to look at 16 waves, and because they're interpolated, you need to look at the next 16 as well, interpolate between the two values, etc. So this is this is like some of the features you need to start creating your own synthesizer. There might still be a few things missing, like for UI controls, you will need to have sliders and other type of controls. At the moment you have just the knob, like you can plug it there and you can see it appears there, or there's also one component called rows. Where is it? Rows. And the way this works is you can have you could have like several rows of knobs. This is how you'd create one row. This is row 1. You can see, I'll show the labels. And now you'll have one row with 2 knobs. You could have another one in another row, and you'd have 3 knobs, etc., etc. And when you control a knob, you get the value that comes out of here that you could use to control, to plug to, for example, on your ADSR, you could plug to your attack, decay, sustain, release, and on your chorus you could plug to the frequencies of those sine waves, or here you could control the frequency of this sine wave and the amount that it's modulating between these two waves, etc. Okay, so I'll show some other new components. There is clock, where at the moment you set the bits per minute there. In the future it will be up there in your transport. There's also a gate show. This component shows the gates for the 16 voices. Like when I play, I'll show it there. The gate coming out from the MIDI nodes. When I play notes, you see playing 3 notes, 4 notes, 1 note. So you could use it connected to your bits per minute, and you will see the gates going up and down at 120 bits per minute, and they all go at the same time. If I would control them by the gate of the nodes, they would start having different times. Okay, so I think maybe at some point I'll do another video with making use of these gates to play notes. You could connect them to your envelopes and trigger stuff. Okay, so let's see if there's anything important. Oh yeah, so this gate latest, again I'll plug to that gate there. This will get the latest gate that went on, and will just coming out will just be that last one. So I can play several notes, and there will be only one coming out. Okay, so that's the gate latest. Can't remember now if what else is there. Mm, I think, okay, so the gate TX and RX, they can be quite useful, because when you have all these wires it gets a bit confusing. So you can put a gate TX there coming out from there, and then you don't need all these other links, and then you put the gate RX wherever you want your gate to arrive, like, and this will work the same as if it was, if there was a link all the way from there to down here. It can be handy for tidying up schematics. So maybe I'll do very quickly, like if you were creating your own synthesizer with let's say with modules, even though the modules at the moment are not very good, it's just beginning. So you would go custom instrument. Actually, maybe even better to get started, because custom instrument is empty, you could start with a sine synth, because then you can see if it's working. Everything seems good. Then you go inside and you actually don't need this stuff. So you could have like an oscillator plugged to an envelope, plugged to a chorus, plugged to your master volume. This doesn't have the button yet. Now I'm going to delete all these. Actually, maybe I should have started with an empty schematic, but it doesn't really matter. Delete. That went wrong. I need a way of doing multiple selection with an area. I think that will come. So delete these, plug this there. And this is your synth. You can see your oscillator inside. Again, as these tables. It's only playing 0, so it's not modulating it, so it's just plays this first wave. If I make it like a sine wave, but let's go, I don't know, triangle. Okay, I think that's probably enough for now. And basically, I think going forward, it's kind of starting to be ready to just create different modules and to allow users to create their own, a bit like this chorus module, and then share them if they want, because they'll be able to export it, send it to someone else, and they can drag it back in. So anyone that knows how to create this kind of stuff, DSP stuff, would be great to see what you can do with it.